going to go ahead and get started. If you haven't found a seat, please do. I need to actually do a little housekeeping first because I need to, if I could, take a photo of you all so I can prove to my boss that I really was here and working and not just out like drinking excellent Italian coffee. So if you don't mind, I need to, if everyone wants to smile, make funny faces, whatever. And I'll get this side, maybe the corner. Okay, right up the middle. All right. Thank you very much. Okay, yeah, by the way, this is not typically my primary phone. My daughter had a phone incident and I had to swap out, so I have a really cool rose gold iPhone now. So I know everybody's envious. Can't have it. Anyway, thank you for coming to this morning's session on Living on the Edge service. Building microservices to optimize consumption for devices using Netflix OSS and Spring Cloud OSS. My name is Mark Heckler. I am a principal technologist and developer advocate with Pivotal Software, Inc. Pivotal are the makers of Spring Boot, Spring Framework, Redis, RabbitMQ, Greenplum, Cloud Foundry, and a huge contributor to Apache Tomcat. You may have heard of us. We like to refer to ourselves as a tiny little startup in Silicon Valley, California. I blog when I get a chance, not as often as I would like, but I blog at thehecklers.org, which is my personal domain. And I tweet all the time. I kind of live on Twitter at mkheck. Is anyone here on Twitter? A couple people. Okay, that's pretty good. I'm also a member of the slightly older and more established social network called Email. Is anyone here on Email? Okay, a couple more of you. That's good. I always tell people that we have a very short time here together today. So I try to hit a lot of things, and I try to hit them quickly, but not so quickly that you don't get value. But I try to kind of throw out a lot of seeds for thought. And after the 40 minutes we have, our time is unlimited. So if I glossed over something quickly, if you felt like I didn't treat something as deeply as you'd like, I probably feel the same way. So let's talk about it. By all means, reach out to me. Again, Twitter from sunup to sundown and a lot of times in between. And email, I'm not quite as quick on responses, but I do respond. So please reach out to me. So who am I? Well, that's a good question. I am an author of several blogs and blog posts. I've co-written one book. I have another one in the pipeline. And I've contributed code and text to several others. I love to read. I love to write. I love to share. I always feel like the more we all share, the more we all learn, and the faster we all learn it. Because your experiences are not mine. So you have experiences I don't, and vice versa. So again, the more we share, the better off we all are. I've spoken around the world on various development-centered topics. Thank you for inviting me here. First time to Codemotion Milan, and I have to tell you, it's really great so far. It seems like every time, though, I come to Italy for a Codemotion, there's a strike. So I'm not sure if it's me. I'm sorry if it is. I'll try to plan that better or maybe sneak in without telling anyone, but so my bad. I'm a developer, so I use what works, and when I find a gap in what works, I try to fill it. Everything I'm showing you here today is completely open source. So please do download the bits and play with it. Download the source code. If you see something that you think is missing or it doesn't act the way you think it should, ask the question. And if perhaps it's in the pipeline, that's great. And if not, we accept pull requests. This is all open source, and we're very community driven at Pivotal. And again, Pivotal is my company. You've probably heard in the context of Spring and Cloud Foundry, it's opinionated. You know, Spring is an opinionated platform. Cloud Foundry is an opinionated platform. What does that mean? Well, in the old days of frameworks and platforms, you had one way of doing things, and that was the way, the one way that the framework supported. Opinionated just means that we try to cover that 80 to 90% of the use cases that are very widely applicable. And if you fall outside of those, you still can get the job done. It just takes a little more effort. But we get out of your way quickly so you can still get it done. If you're in the 80 to 90%, it's very quick, very streamlined. Has anyone, I guess let me ask this before I get too much further into things. Who here is a Java developer? Excellent. You just made my day. For the other 5 of you, get out. Just get out now. Just kidding. Spring Framework experience? Spring Boot?
10 years ago.
Oh, well, you can stay then. That's all right. Yeah, I'll give you a little bit of a history lesson here shortly, but that's good. You probably, especially you've probably heard that Java is a lot of boilerplate. It's a lot of code. It's very verbose. We're going to shatter that myth today, hopefully, in very short order. So also Java champion, recognized by my peers as contributing to the Java community. If you had anything to do with that, thank you very much. Really appreciate it. And I've survived many monoliths. I used to work for consultancies and then Oracle. I have the scars to prove it. And I was a reluctant convert to microservices, but they bring an awful lot to the table that just can't be dismissed. So I am a convert, and you'll probably see that as we go along. And again, seeker of a better way. Always looking for a way to deploy more production-ready software to production. Not undifferentiated heavy lifting, but software with real business value. So, as I like to say, non ho ancora parlo bene l'italiano. See, I can't even say it. I can't even get my tongue around it. I'm presenting in English for your safety. Does anyone recognize this photo? Vogons? Anyone? Wow, this is a tough room. I thought I had it made when you guys were all Java devs. Yeah, Hitchhiker's Guide to the Galaxy. Listening to me try to speak Italian, as you probably know, just from the brief exposure. It's sort of like listening to a Vogon recite poetry. Very painful. I won't do that to you. So, we'll launch right in English. We won't be talking about him today. Does anyone recognize him? Oh, thank goodness. Okay, good. With a title like Living on the Edge, sometimes I do get the question. But this is what we're going to be talking about today. A little history lesson. In the bad old days of enterprise Java, it was kind of disastrous. It was very cumbersome, very onerous to develop server-side Java apps. So, among other people, Rod Johnson he felt there had to be a better way, and he created what became known as the Spring Framework. And over time, the Spring Framework grew to incorporate a lot more capabilities. The problem, of course, that anytime you encompass more capabilities, it gets to be a little larger, and you know, sometimes people feel like that's rather large and cumbersome as well. So looking for a better way to do that, Spring Boot was born. About 3 years ago, Spring Boot came into being in general availability. And Spring Boot sometimes is referred to as a micro framework. I don't really like that. I don't have a better term for it. But what it does is streamline the use of all of the Spring Framework's capabilities in a very easy to consume package. As it says, go from 0 to app in under 5 minutes. It covers a few different things. It has Spring Boot starters, which allows you to bring in and simplify your dependencies. It has auto configuration, which gets you up and running and concentrating on your business value quickly, as you'll see. Spring Cloud is kind of another star of the show because, as it says, designed for fragile infrastructure in partnership with Netflix. Anyone here of Netflix? Anyone a Netflix subscriber? Okay, the rest of you just save yourselves. Don't subscribe. A lot of great programming out there. And as much as I travel, it's kind of cool because I get exposed to what's available here versus there, and which also is kind of frustrating because if you're in the middle of a series, anyway. Netflix. Sometimes they develop software straight out of the gate, open source it. Our engineers take it and say, you know what, we can abstract that and make it more broadly applicable. Because Netflix deploys everything currently on AWS. Sometimes we work with them from the get-go and try to make things more consumable across the board early on. But we love Netflix. Netflix loves Spring Boot and works with us on Spring Cloud as well. So what do I mean by fragile infrastructure? Well, the internet. For starters, if you have multiple instances of multiple microservices, chances are you'll lose connectivity at some point, or a server will crash somewhere, or something. So you have to incorporate that. In the old days of architecture, you tried to make sure at all costs that your monolith did not collapse, because if it went down, everything went down. You understand in a networked environment, in a distributed system, that there are going to be failures. So what you do is plan for them, architect for them. How do you do that? Well, you have certain components that you need to exercise, certain patterns that you need to implement. And some of these are actually Netflix OSS, some of them are Spring Cloud, but I kind of run down the quick list as we go, and I'll hit this rather quickly because I want to leave as much time as possible for coding. But there are kind of two main thrusts of microservices architecture enablers, as I like to call them. One is to help your distributed system interact. Your various microservices interact with each other. And the other is to help us reason about them. A colleague of mine likes to call us meatware. And it's important for us meatware to understand what our systems are doing. Not only so we can develop good systems, but so we can fix them when they break. I'll give you a quick rundown first. Is anyone here familiar with 12-factor apps or the concept of cloud-native applications? Okay. 12 factors obviously has 12 factors, but it kind of covers a dozen things that you should do to make your application a cloud inhabitant, cloud native, if you will. I hate to kind of blur those, but we'll go with it for now. And there are two that I kind of call out as first among many. One is to bring your dependencies with you, or bring your toys with you, as I like to say, which keeps your dependencies under your full control at all times, keeps everything portable. And the other is to externalize your configuration. Because in a monolith, if you have to load config, or perhaps you have configuration settings sprinkled throughout your code, it's probably not a big deal. I shouldn't say that. It's not as big a deal. How's that? Because you're probably not going to open source your entire monolithic application for your company overnight. You're probably, if anything happens, you're going to have to work on a rebuild, redeploy of that entire application. But in microservices, you need to be more nimble than that, right? If a backing service goes down, you don't want to have to rebuild, retest, redeploy your consuming service. So what you want to do is externalize all that configuration. It also has the advantage of if your boss comes and says, hey, you need to open source our library today, you don't risk exposing your credentials. Because if you have credentials and key information within your code for where to find services, you can expose a lot more than you ever intended to. So you need to externalize that. The Netflix application I mentioned before, the Netflix.com, that's fed by about 500 different microservices. Now, what do you think the odds are that any one of those is the only one of its kind running at any point in time in the world? Close to zero, right? Rapidly approaching zero, you hope. So let's just say for argument's sake that each of those 500 microservices has 10 instances. That's 5,000 different instances of microservices having to pull config and deal with that in some manner. And for us to have to deal with in some manner. We use the Spring Cloud Config Server to centralize that configuration without inserting a new bottleneck. It allows us to maintain that in repos. So a Git or SVN repo, but since it's 2016, we'll use Git. And of course, that allows us to audit and version control, just like our code, right? It exposes APIs to our application so that it can feed parameters upon request to any of our instances of any of our microservices by their identity. We also need a way for services to register and, as I like to say, see and be seen. Because if in an ephemeral world, if an instance of a microservice dies here, your platform may spin up a replacement here. And that's all very dynamic. So a consuming microservice needs to know where to find an instance at any given point in time of a backing service. Netflix uses Eureka for that, as well as some other things, like some of the config. I'll show you that as far as the service registry goes, but obviously other examples are available to be consumed via Spring Cloud as well. You need to be able to implement a circuit breaker. Just like your house, if something fails, the wiring fails in your bedroom, you want to hopefully just lose power to your bedroom, or maybe to your house, but you don't want to lose your house. An effective circuit breaker enables you to do that, to degrade gracefully. In the Netflix application, if you lose your recommendation engine, you never just see an empty bar across the screen. You don't necessarily see, here are recommendations for you, but you might see, here are popular shows in your area this week. So it degrades gracefully and still provides value, still keeps the application fully delivered, just at a slightly degraded level. Then you have things like load balancing, client-side load balancing, so that you don't insert a new bottleneck into things. You have intelligent routing, so that you can strangle the monolith, so that you can reroute without rebuilding your code and redeploying and retesting. Asynchronous messaging via Spring Cloud Stream. Has anyone heard of the reactive programming model? A couple, maybe? Yep, okay. It offers a lot, and I don't mean to simplify it to simply asynchronous, but that's one element of that. And currently, a lot of people are looking at that and thinking, how can I implement that? Does it make sense? But when you sometimes just need to fire and forget, and you don't need to block, you don't need to wait for a response, you may already have the pieces at hand in your organization. Things like message queuing, RabbitMQ, and Spring Cloud Stream fully supports that. Then you have Sleuth, which covers distributed tracing. In a microservices world, when you have interactions among several microservices, how do you know what's good? How do you know what's bad? Is a full interaction across several microservices at 200 milliseconds good? Or is that a problem? And that's where distributed tracing comes in, things like Zipkin and Sleuth. Zipkin was a Twitter project based on a Google paper, the Dapper paper. We actually have Adrian Cole from Twitter who is working on this now with Spring Cloud Sleuth. So, and of course security as well. OAuth 2 and your HTTP security that we implement as well via Spring Cloud Security. I'm not going to get into that as much today. I'm probably not going to get into half of this today because I'd rather cover this much well than this much poorly. So with that, let's just jump into this. And by the way, I need to lean on you on the front. A couple of things. One, I never remember to pop up the links at the end. So please do remind me to post the links at the end because I have a meta repo and several other links that are helpful. And the other thing is that I intentionally sprinkle some typos in my code just to see if you're paying attention. So if there are any typos in there, it's on you, okay? I don't. But the faster I type, the more typos get in. I don't know why. Okay, so let me switch to mirror display. And okay, can we see that? Okay, let's get started here. And that's actually a little more readable. If anyone can't read this in the back, please do let me know. I'm just going to charge forward unless I see you doing this. So, all right. Since we're going to be using Spring Boot and Spring Cloud for our microservices, this is kind of our starting point. You may have heard this affectionately referred to as start.spring.io. It's the Spring Initializer. This, too, is open source. And if your organization has a certain number of libraries or a certain set of libraries they want to offer up as dependencies and limit your selection, bad, 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 but let's say they have a valid reason for that, they too can implement the Spring Initializer in-house and modify it to suit their needs. So this gives you many options for getting started with microservices in a very painless way. You have different defaults you can choose. If you're a Maven developer, you can choose a Maven project. If you're a hipster, you can choose Gradle. It's all good. Okay, good. We have a Maven crowd. That's good. that was a test that shouldn't get me anything thrown at me. So okay, you can choose your version of Spring Boot. So a couple of production versions. If you snapshots, you can provide meaningful defaults. As you can see, that there are some provided for you. I have expanded this to the full version to give you some kind of an idea of the options that are available kind of behind the scenes. You can package as a jar, which is an Uber jar. It brings all of your dependencies and bundles them in one neat package so you can deploy to anywhere with a JVM. Very nice. You can, if you're still stuck in the past and you're still using an application server, you can still use a WAR file. You can deploy as a WAR file, but it does violate that 12-factor, those 12-factor principles. So we always like to encourage the jar, but do what you need to do. I'm starting to lose my voice already. This is bad. You can choose your Java version, 1.6 through 1.8. You don't even have to use Java. You can use Groovy or Kotlin, but who wouldn't want to use Java, right? Okay. Has anyone ever played the game of whack-a-mole with dependencies, where they have multiple dependencies and something just isn't working? Only, and you check Stack Overflow, you check Google, nothing. Only to find out after several hours or days of searching that version 3 of library A doesn't work with version 7 of library B. Nobody's had that? Oh, you're lying. You're just lying. So if you back it up from version 7 of library B to version 5, everything works. And congratulations, you've found a new conflict, a new problem. That doesn't always feel really good when you're doing it, but it is what it is, right? With Spring Boot, those versions are synchronized. For anything that's shown on this list, all of these are version synchronized with the main starter BOM. So that allows you to forget about that game. If you want to bring your own dependency, if you want to specify your own version, you still can, but you don't have to. It simplifies things quite a lot. Sorry. Okay. Hopefully I spared you that. As you can see from the list, it's rather exhaustive. These are all battle tested with this particular version of boot that I've selected. You can go through and choose off the menu if you want. I usually don't because, again, it's quite a long list and I can't find things easily, so I just switch back to the simple version. By the way, you can get to this via curl or via the Spring command line interface, but I always use the web interface because it's so pretty. So it's, isn't it nice? Okay. All right, so to get started, remember I said there are two things that you kind of need for your microservices, or two potential areas to cover. One is to enable your microservices to interact, and the other is to enable you to understand your architecture. We're going to start with the first here with a config service, and I'm going to specify my dependencies that I'll need for this. I'm going to bring in the library for the config server, generate the project. Now what happens at this point is it doesn't generate code per se. It'll create your Maven POM or your Gradle build file. It'll zip everything up. It will actually do your main method, main application method and class, but that's it. So it zips everything up. You download it, open it up in your IDE, and you get started coding. So it's entirely in your hands. So I'm going to download this, unzip this, and open this up, favorite IDE. I won't even ask what your favorite IDE is because I know it's IntelliJ, right? Okay. It doesn't matter. This works with NetBeans. It works with Eclipse. We even have STS, which is Spring Tool Suite, which is custom Eclipse. So we're across the board, all good. So can everyone sort of read this? All right. So I'll pull up the application properties. Since this is my config service, I can't be turtles all the way down. I can't access my config service to feed my config service its properties. So I'm going to have to specify a few basic defaults here in my application properties. This file is read upon application initialization by a Spring Boot app. So we're going to give it just a little bit to chew on here. We're going to tell it what port to run on. And we're also going to provide it the Spring Cloud Config Server Get URI. What this does is point to a Git repo. This can be a local Git repo or GitHub, GitLab, Bitbucket, what have you. You can point it to a repo on a network drive or on your local hard drive. I wouldn't recommend that for production, but it works really well for demos, so we'll just do that for now. By the way, a few of the things that I do are optimized for demos, and they're not necessarily optimized for production, and I try to point those out. So if you have any questions about something that looks a little weird that I'm doing, ask. Don't assume that, well, Mark said this is how it should be done in production at a large scale. It may not be, and I'll happily tell you that as we go. So YAML microservices config. You can specify your repo files in key value pair property files. You can also use YAML, which gives a little more structure. So that's entirely up to you as well. So I'm also going to go to the main application class. I'm going to enable config server. So I provided an annotation, and I started. Lots of code, right? Tons of boilerplate. Yeah, not so much. All right. So while that's coming up, I want to give you a sneak peek at the repo that we're going to be using behind the scenes for our config. And as you can see, there are different YAML files or different property files you can use to feed the Spring Cloud Config Server. Here we have our application.yaml, which provides a set of basic properties for all applications that identify themselves as anything to the config server. We also have, you can specify by profile or platform, like application-cloud. So if you specify a profile for an application, it can reference those properties as well. If a service, for instance, identifies itself as an edge service to our config server, it will get an additional set of properties. If there are any conflicts, more specific wins. So easy peasy. To give you an idea what that looks like, here's our edge service .yaml file, and as you can see, it's typical YAML. You provide some properties. So pretty simple. We see that we've started here on port 8888. So let's go ahead and make sure everything's running as it should be. And this is an example of the properties that would be served up to an instance of a microservice identifying itself as edge service. So we see here our basic application properties. And we see then that we have our properties for specific to-edge services. So it's not terribly sexy, but it works really well, and it's very essential to what comes next. So with that, what comes next, right? We'll also need to create a service registry so our microservices can find each other. We won't need our dependency for a config server, but what we will do is pull in our properties from a config server, so we'll need our config client dependency. We also need to bring in our lib for Eureka Server, generate the project, save it down, unzip, open it up, and let's see, how are we doing on time? Excellent, okay. So, a little bit different case here. With a Spring Boot application, when the application is initialized, the application context is established, it hits that application or looks for the application.properties file. But when you need to tell it to find a config server, you kind of need to get out in front of that application initialization, kind of in a bootstrapping phase. And the easiest way to do that is to change our application.properties file to a bootstrap.properties file. And that way we can provide the information that points it to our config server. So we'll provide the Spring Cloud configury. If you remember, we put that at localhost 8888. See, I caught that one front row. You're off the hook on that one, but next one is not free. So, okay, and then, whoops, Spring application name. We'll call this Eureka Service because I'm, again, not great at naming either. And then we will provide an annotation, enable Eureka Server. Again, so far that's it, which is exhausting, right? A huge amount of code. So at this point, you probably could take the rest of the week off and tell your boss you're exhausted. You've already created a config server and a service registry. So that's it, right? So anyway, man, you guys are hardworking. Nobody even lit up on that. That's crazy. We see here that it's initializing on port 8761, which is what was specified in our config properties that were served up. So let's go take a look. And this is the Eureka dashboard. The dashboard itself doesn't provide any value to your microservices. It provides value to you so that you can see what's going on in your architecture, in your system that's running. There's a lot of good information here, but kind of the key bits are your replicas. In the case of this, we have no replicas. We're running in a non-highly available manner. For a demo on a laptop, that's fine. Production, you wouldn't want to do that. However, even in HA mode, or even if you're running solo and that goes down, your microservices can still run. Remember, the idea is survivability. Once they initialize, they will look for the Eureka server to register. If it goes offline, they'll continue to poll, and at some point, they'll reestablish a connection when it comes back online. Life continues going along. The other thing that you'll see is that there are no other microservices currently registered with Eureka. We'll fix that. So that's next. Now it gets to the fun part, because that was kind of the setup. That's the stuff you need to have in place before you can really do any other things that are your business value type of things. So let's create some business value. Is anybody here a fan of quotes, movie quotes, or like historical quotes, anything? Jeez, okay, well, okay, great. Now I feel really good about myself. I collect quotes. I like really witty quotes, probably because I don't come up with any myself. But no quote of the day applications on your phone at all? Nothing? No one? Wow, okay. Clearly you guys have a better life than I do. Okay. I'm going to bring in some dependencies for our backing service. This will be a quote service that will store and retrieve quotes. The first thing I want to do is expose a web API. We already have config client specified, so it'll pull its properties from our config server. If it's a quote service, we'll want to be able to store and retrieve quotes. I'll use JPA because, as a colleague of mine likes to say, sometimes we make poor life choices. I'm also going to use H2 because it's an in-memory database. It's very quick to spin up. For production, you probably wouldn't want to use it. You'd want to use something a little more reliable that wouldn't lose data, not H2, not Mongo. And then if you want to bring in REST repositories, is anyone here familiar with the repository pattern, domain-driven design? What we want to do is this allows us to create Spring Data repositories and expose them as REST APIs. I'll give you a quick demo of that as well. Let's see, I'm going to bring in hate OAS. I know some of you may pronounce that differently, but you're wrong. I've worked on a product called OAS in the past, and I can tell you hate OAS is the right pronunciation. Bring in the HAL browser, which is for the price of a dependency, a free dependency, lets you exercise and test your REST endpoints. Very nice. I'll bring in Stream Rabbit, although I'm almost sure we won't have time to get to it, but I'm an optimist, so what can I say? And let's see, what else? That's probably good. So we'll generate our project and save it, unzip it, open it. Similar routine, right? But very streamlined. We'll also go to our application properties, and we'll rename that to Bootstrap properties, and we'll provide a few different, few useful defaults like the application name. This will be our quote service, and then we'll point it to our config server, which is localhost 8888, and then we'll go to our main application class, and we'll enable Discovery Client so it can register with Eureka, see and be seen, right? Okay, so we need to do a few things. Since this is our backing service, we need to store something. I'm going to create, again, a JPA entity. This is a JPA annotation, not a Spring annotation at all. But I'm going to call it class quote, create a class for my quotes. I'm going to create some meaningful memvars here. Long ID, private string text for a quote. A quote would also probably have, not that, a source. And then we'll create a constructor. Hello. Come on, okay. IntelliJ is messing with me here. Okay, nor constructor for JPA and JSON. And then we will do a constructor, there it went, a real useful constructor. We'll also add some getters. I was having a chat with a friend of mine not that long ago from the UK, and I mentioned, I don't even know how it came up. We were talking about everything under the sun, and we mentioned, or I mentioned, must have, getters and setters. And he said, you know, I always like to refer to them as accessors and mutators because I think it sounds smarter. So if you want to sound smarter, accessors and mutators it is, but getters and setters is faster. So I'll just cut to it. And the toString method we'll throw in there. Now we're almost done, but since this is a JPA entity, we need to also somehow designate what our corresponding member variable for our ID field is and how our underlying repo is supposed to generate that value. So done. Again, since we're going to be using REST repositories, we need to specify a repository REST resource, which means that we're going to extend an interface. We'll call it our quote repository. No typos there, right? Okay, yep. And we're going to extend an interface within Spring Data called CRUD repository. We'll specify the type of the entity being stored and its ID field. And that's all we need to do for a basic level of capability. Again, opinionated, the 80 to 90% use case. But we're missing something. At this point, we have no test data. So let's go ahead and create some very quickly. We'll create an instance of the command line runner. And is anyone here familiar with Java 8, single abstract methods? Okay, functional interfaces, excellent. That's what I'm going to provide here for our run method. And since I don't type as fast as I would like to on this, I'm going to cheat and copy that in. Because as you can see, this would probably take way too long to copy in. Boom, right? Okay, and because I like to see what I'm doing, I'll do a find all for each system.out print line. And that way, we can see what we get when we start up. So I'm going to start this up now. And wow, we're getting close on time. So I'm going to fly through the rest of this so we can see what we have. While that's starting, I'm going to go ahead and, well, it started. So very quick, right? We see the quotes that are populated in here. I will go here and we'll make sure that this starts. Localhost 8088/quotes. And we see we have our quotes. I'm going to skip some of the other stuff that I usually like to show because I really want to get to kind of the fun stuff, the edge service. So I'm going to create our edge service. And I'm going to remove a few things here that we don't need. JPA, H2, and the REST repositories, because that's in our backing service. I'm going to add in our dependencies for Hystrix, Ribbon, and Zool. Generate the project. Save it. Open it. Open it again in our IDE. Go to our application properties. Again, we'll rename these to Bootstrap properties. Spring application name is Edge Service. And the cloud configuration, again, is localhost 8888. OK, so we'll go to our main application class. We do things a little bit differently with our edge service because we want to be able to use a Zool proxy. And I may get to a little hint of that quickly. We'll see. I'm going to create a class quote here. Typically, what you would do with an edge service is streamline and munge inputs from multiple different backing services. For expediency, I'm just going to basically bring it through straight. But it's an example. And we have the text, string source, and constructor. Again, no arg. And again, useful. And getters. And we'll do the toString. OK, good to go. Now, for our edge service, what we'll need to do is create a means of accessing this from our web APIs. So we'll create a REST controller, call it class quote controller, and we will do a request mapping. And we will point that to quote orama. Right? OK. And I'm really close on time, so what I'm going to do is just kind of cut some of this out and show you the Zool part, the microproxy part. So let's go straight to that. Because what we have here already is already a working application. I was hoping to get further, but that's why we have the unlimited time after, right? So once this starts, and it is started, we see here our quotes that we're pulling up from our backing service. And then if we go to our edge service, we see here that we can, if you notice the QS/quotes, oh, OK, front row, what did I do wrong here? All right. Oh, let's see here. Well, let's go ahead and do this, and we'll just run through this. So we'll do a public quote get, let's see, get random. Oh, that would, let's see. I didn't finish what I was doing before because I was trying to cut to the front end of it. So what can I wrap up here on? Because we are out of time. What I'll do is to create a REST controller here, call it class quote controller, and we'll do a request mapping / random. Because this is kind of nice to be able to, again, this is a quote application. We don't necessarily want to see all quotes. We want to see a random quote that we can choose and pull up. So we'll do a public quote get random quote. And we will auto-wire in or inject our quote repository. At this point, we'll return our quote repository dot what. Because we don't have any method outside of that, again, 80 to 90% use case. So we need to be able to provide something that falls outside of there, something along the lines of a query, like select Q from quote Q order by rand. This will return a random order list of quotes, get quotes random order. And this By providing our method signature, Spring Data is able to grok from our query that we're providing what it needs to do to provide that implementation. Again, very enabling for providing business value. So we'll do a get quotes random order, get the first one, and we'll return that. So really quickly on the wrap up, I'll go ahead and restart this. We'll take a look at that, and then I'll cut you loose. And again, I need to go back and show you what the links are, because that's where everything is out there to continue the journey, or ping me. So we'll go back to this. And of course, we still can get to our quotes. We can also get to our random quote. So very nice, very neat, very tidy. Really wish we could have gotten further, but it is what it is. So let's go ahead and wrap up here. Mirror the displays. Go back to here. And here are the helpful links. Much, much, much more to cover. The bottom is a meta repo, which actually has links to all of the different microservices fully developed. If you'd like to start there or start on your own and come back to this, the top one is the guides link, which has a lot more in depth on how to create each of these and many others using each of the different Spring Cloud components. And of course, boot and cloud source code. So, in summary, microservices can be hard, but they don't have to be. If you build a robust infrastructure and make it secure, you can do this. Netflix does it, and they use it to great success. So thanks for coming. Have a great day.